Hello, everyone. We've got coming up just next, Diego's going to be talking about adversarial countermeasures, which I think is a really cool topic. It doesn't really get talked enough about. Diego is a leading expert kind of in this field and also in threat hunting, been in the industry for 9 years, and is currently working at the Commonwealth Bank of Australia. You're in the threat intelligence team, is that correct?
Yeah.
Perfect. Yeah, so I think whenever we get a chance to get someone from one of the big companies talking about threat intel, I just think it's really cool because we kind of get a little bit of a chance to benefit from all the hard work that you're doing. So can I get a massive round of applause for Diego?
Thank you. Hello, everyone. No, I'm not in the threat intel team, actually, now that I think about it. I'm just under the detection and response team in CBA. So, what are we talking about today? It seems like it is this thing that we call active defense. So, the reason why I chose this topic is because I'm very passionate about defining frameworks that help us make sense of cybersecurity in general. There are many ways to slice and dice this. I chose to not make it technical, to not go into the nitty-gritty details, and provide more of an overview of what I think the active defense space is, what does it mean, and hopefully what I want you guys to come out of here with is potentially a new mental model. That's what I'm going for here, is trying to work, refine, and define a new mental model, a new lens for you guys to start seeing how active defense plays a role in today modern organizations. So a little bit about me. I grew up in Argentina. It's a weird place, so, but it's my place, or it's the place I come from. And I've been in Australia for a decade already. There are a few little details about me there. When I say that I'm from Argentina, people immediately assume that I'm good at soccer. So, they think soccer, asados, like barbecues, meat, and tango. So, of all of those three, I do like barbecues, so that's good, but Argentinian barbecues have coal. So it's not like a plank with, like a hot plank. It's the smokiness of the coal of the wood. That's the kind of barbecue I'm talking about. The second thing, playing soccer. Look, I love it. I kind of suck a little bit, but I love it. So I do it anyways. I just do it, and I get injured all the time because I play with people 10 or 15 years younger than me, and I think I'm getting to that ball, but no, and then I hurt myself, and that happens almost every time. But I keep doing it because you don't have to be an awesome expert to do the things that make you feel joy, isn't it? That's the thing. And tango, I happen to dance tango. So raise your hand if you dance tango. Oh, wow, I didn't think I was going to get any hands showing up. Awesome, that's great. Tango is pretty cool, guys. I would suggest if you don't dance, just give it a chance. Go with your partner, just have a go. I've been doing cybersecurity for quite a long time. I did this in Argentina as well, on a very ad hoc capacity, firewall configurations, that kind of stuff. But what a lot of people don't know about me is that prior to being in the security world and IT world, I studied philosophy. When I was halfway through my thesis, I relocated to Australia, and I never completed my degree. Never ever completed it. But I did 33 subjects and wrote a whole lot of stuff. And you will see that shining through in this presentation and in the stuff I write. I write the Tales of a Cyber Scout. I don't know if you read that or not, but if you want to read it, you'll see what I mean. I've created a threat hunt framework as well which I call A mode 2, and I don't like it anymore. So it needs a bit of updating. Getting there, we'll get there. It's pretty cool still. Currently, what I do is that I lead the threat hunting team at CBA. We have a team of dedicated threat hunters, and it's interesting work. We have a lot of fun, and also sometimes it gets really serious, but mostly fun stuff. Sorry, was that a too long who am I introduction? I think I'm going to move on. So, traditional cyber defense, the problem with traditional cyber defense is that we think in terms of the castle and moat approach. So we think in terms of, I've got a little island that I need to protect. In that island, I have my users, my data, I've got my resources, and all I have to do is defense in depth, right? So let's build just concentrical walls and moats. Even we could put sharks in it so that nothing comes in and out without a bazillion towers observing what's going on, what data is coming in, what data is leaving our organization. The castle and moat approach is very passive and very reactive because what you're mainly concerned about is data coming in and out of your organization and just building gigantic walls to protect that. However, this is what we normally think of when we think about cybersecurity. I know NIST is protect, detect, respond, but this protect, detect, respond, identify, protect, detect, recover, this whole thing is very based on building these walls around your castle. There are a few challenges, though. The problem is that we have, nowadays, quite a distributed environment. If you, for example, build an application for your users, that application is outside your castle. Somebody somewhere else in another castle, in another city, is using that application. Yes, maybe the backend talks to your castle, maybe it talks to that island that you're protecting, but the clients, the users that are using your application on the other side, they are exposing that application to environments that fall outside of your control. So we have hybrid environments, we have distributed environments, and there's also another problem to the castle and moat approach, which is insider threats. Threats can also grow from within. So then probably our model fails a little bit because you're always looking outside, but what's happening inside? I sound like a life coach. What is happening inside? The problem with defensive approaches is that your OODA cycles are slower. Everybody here is familiar with OODA, I believe, but if not, I'm going to expand a little bit on it. It means observe, orient, decide, and act. We all get indoctrinated in this. Colonel John Boyd from the United States Air Force created this. Somebody told me once that almost all security models can boil down to OODA. And I think that's true, but also OODA can boil down to some very basics of human understanding and decision-making processes. When your OODA cycles are slower, when you rely on purely defensive and protective models to understand the threat landscape, what it means is that you don't update those as quickly as you need, which gives your adversaries time to update their tradecraft to target you. It doesn't mean that your protective model doesn't get updated. You may inherit or you may approach the Essential 8. Okay, let's implement the Essential 8. Awesome. It has high rates of effectiveness. It's amazing. But then what happens with all the little things that the Essential 8 don't cover? Maybe somebody will update the Essential 8 sometime from now, but in between now and then, you may have windows of exposure that you need to address. So I say that this castle and moat approach is highly vulnerable to what I call the 3 tactical disadvantages of cyber defenders. What are those? Well, I'm not going to hold the mystery too long. I'll go into it. Some people have been talking about this kind of like tangentially yesterday. In some of the talks, I started hearing defender's dilemma and et cetera, et cetera. This is born out of the defender's dilemma. So what's the defender's dilemma? Attackers only need to be right once. Defenders need to be right all the time. That's called the defender's dilemma. The 3 tactical disadvantages are a way to explain that. Disadvantage number 1, and you'll probably relate to this as I go through it. The first disadvantage is environmental volatility. Who here hasn't had the experience of not knowing what even is deployed in your environment? So the more technologies you have, the more layers to the technology stack, the more people, the more processes, the more points of failure you're adding to your environment. It's just statistics. So the more decision points and brings the complexity of your environment up. And what happens nowadays with Kubernetes, with containerization, multi-clouds, on-prem, it's SaaS, PaaS, IaaS. So we have so many different technologies that make up our infrastructure that it's really hard to know what exactly is deployed in my environment. I know it freaks people out. My CMDB is awesome. Probably my CMDB is a true reflective of what my environment looks like. We all know that it's not the case. Is it the problem of the CMDB? I don't know. Maybe when quantum computing and AI combine together, we're going to have like an instant picture of how assets look like in our environment. In the meanwhile, what happens is that maybe you had this tool you were using in your laptop, and tomorrow it's not anymore. It's not there anymore. Why? Well, some engineering chief in some corner of the company decided that that tool wasn't necessary anymore, and you didn't get the memo. You only get the experience of the tool not existing anymore in your tool stack. Or perhaps you had access to this cool little thing, cool little application, and suddenly you cannot access it anymore. Why? Oh, well, somebody decided to change the permission groups, so now you have to apply to another permission group. So these little things happen all the time, and the more complex the organization is, the more that happens. So let's just accept it. Your environment is volatile. It is a tactical disadvantage for you as defenders, because if you don't know what you're protecting, if you don't know whether that proxy, that firewall is blocking traffic coming from here or there, you don't know what you're protecting. So that's one of our disadvantages. Attack vector uncertainty is the second one. You never know where an attack is going to come from. You don't know what specific combination of attack chains or attack vectors combined into an attack chain are going to impact one of your many weaknesses in your attack surface to land a successful reverse shell in one of your servers or in one of your company's assets. It is really hard for us as defenders to predict that. Because to predict that, we need to actually combine a lot of data points. And yes, AI is trying to get there. It's not there yet. It's trying to get there. The ecosystem hasn't integrated this yet. Signal ambiguity is what every SOC analyst has faced at some point in their lives. Raise your hands if you've been a victim of alert fatigue. Yes, there you go, like half the room. So alert fatigue is very real. And yes, AI is saying that it's going to solve that. It's not quite there yet. Maybe one day when we have quantum computing, maybe. But in the meanwhile, what we try to do as defenders is to reduce the noise, filter the noise, and come out with a signal. This is the old problem, guys, is the needle and the haystack problem. and it will continue to be. It's one of those conundrums of humanity that I like a lot because you can interpret that in many ways. I've heard some clever solutions over the years. People saying, I would burn the haystack, and then that's how I grab the needle. But then maybe you melt the needle, unless it's not made out of, well, as somebody said, I will use a magnet to attract the needle. I like those things. But I think the needle and the haystack problem and the signal-noise ratio problem will always be there. It doesn't matter how cool, quantumized, futuristic your technology is, it's always going to be there, because guess what? As your search algorithms and capabilities get stronger, the telemetry that needs to be sifted through also gets bigger and higher. So why do we have so much alert fatigue still? When I started as a security analyst almost 10 years ago, I remember complaining that our slow-moving SQL backend SIEM was not giving us the context that we needed to understand what was going on. So there was an alert. We had no idea what was going on. Maybe we got some sysmon logs, maybe some Windows event logs there, maybe some syslog from here, the firewall. We had no idea what was going on. It was really hard. EDR didn't exist a decade ago. It was just AV. Then EDR came into the market, and there was an explosion of telemetry. Now we had all the telemetry we needed, but then it's too much because we haven't figured out the way to tune the signal out of that telemetry. So rest assured, AI is going to come to save us, but at the same time, our capability to absorb telemetry from our devices and infrastructure is going to increase, so the fight continues. How do we counter the 3 tactical disadvantages of cyber defenders? We need a way we need to think differently, all right? So we really, truly need to start thinking differently. What do I mean by this? How can we reduce informational uncertainty? If you cannot control the information coming to you, perhaps you can seed information on purpose. That's one way of controlling information uncertainty. And you will see what I mean in a second. If we cannot fully reduce ambiguity, can we use ambiguity to our advantage? Can we introduce ambiguity for the attackers? So when an attacker comes in and they see some fresh credentials that some admin left in some code base, or developer left in a code base, or group policy, whoever here has done a pen test or a red team before know what I'm talking about. Perhaps you're going to try those credentials, and actually those credentials were planted there on purpose by the defenders. So you start introducing ambiguity and using it in your favor. What I've described so far is sort of the problem space. And what I think the answer to this is to start thinking with a new mental model. And this new mental model I call active defense. And it's not a new concept, it's just a poorly defined concept. And I think what I'm trying to do is bring some coherence into the space and create something that you guys can walk away with that is going to be easy to consume. We need to see beyond the unpredictability of the future. Can you do that? I don't know. People talk a lot about unknown unknowns. Who likes the unknown unknowns? So that's Rumsfeld, the Secretary of Defense, I believe, from the US. Yeah. So this guy was, of course, he said, we have known unknowns and we have unknown unknowns. And I always laugh because what even is an unknown unknown? Let's just think about it for a second. An unknown is something so completely random, you have absolutely no ability to even start predicting what that is. An unknown unknown is absolute entropy, 50-50 chance. You cannot, by any means, predict an unknown unknown. That's the whole point of it. If you could, then it's not an unknown unknown anymore. So you cannot risk manage, programmatically predict, and risk manage full randomness. That's what I believe, at least. Active defense is about starting to think in terms of adversarial engagement space. You know that little castle and moat approach, which is really nice? We build defenses around our castle. What we're missing there is the realization that your company is in the middle of a warfare scenario. Your assets in the digital age are there for anybody to take. Yes, you build protections around it, but anybody with not enough smarts and technology can try to grab it. And that's why we have cyber criminals and threat actors. So active defense is about starting to think, I am part of a bigger thing here. I'm part of a conflict space. I call the adversarial engagement space because there's full of adversaries out there trying to profit from your good stuff. So let's settle something. It is impossible for you to not engage cyber threat actors. It is impossible. You will engage cyber threat actors, either knowingly or not, either passively, reactively, or actively, but you will be engaging them. So then I thought, wait a second, this kind of starts to look like a model. There are two ways to engage adversaries. You either engage them on the outside of your perimeter or on the inside of your perimeter. So there's two territories to engage cyber adversaries or cyber criminals. Once they are inside or whilst they are still outside. And there's also two modes of engagement. You can engage threat actors by discovery or by disruption. Discovery is your intention is to observe and learn. That's what you want to do. Disruption is your intention with disruption is to evict, to block, to intercept, to interfere, and effectively evict the threat. The kind of thing that your response team would do if there is a data breach. So when we combine these modes of engagement and the territories of engagement in a 2x2 matrix, we end up with something like this. You have your external and internal perimeter, and you have your disruption and discovery axis. These two axes will create, or coordinates will create 4 quadrants. Interception, mitigation, reconnaissance, and scouting. These are ways in which you will be engaging cyber threat actors out there. When you are trying to engage a cyber threat actor on the outside with the intention to disrupt their operations, you're effectively trying to intercept that. And the best way I have to exemplify that is the shadow server talk yesterday. That's what the shadow servers guys do. They mainly operate in the interception and reconnaissance space. They go outside, they plant decoys, they plant lures, they scout or produce intel from the external environment with the intention to also intercept the threat actors by sinkholing, by doing takedowns, and et cetera, et cetera. When you internally want to disrupt a threat actor, that's the domain of classic hardening, incident response, patching. That's what you do. How do you control a threat once it's on the inside? With the purpose of purposefully stopping the attack, stopping the damage. You want to contain the damage, you want to mitigate the damage, you want to evict the threat actors, and then you want to restore functionality. That's the domain of mitigation. Essentially, what it means is there's something already going on. There is some damage already happening inside my environment. What I need to do now is just stop the bleed. I need to mitigate any further damage. Scouting is the domain of threat hunting, adversarial emulation, and a few other bits and pieces, which I'm going to go into in a second. But just bear in mind, the purpose is you either want to disrupt your threat actor or you want to learn from them. Learning from them is not merely being passive. You're actively, purposefully, with intention, observing the adversary, learning from that, extracting useful information that you can then use in your environment. Now, what's the problem we normally face? Traditional cyber defense only focuses on one sector of that quadrant, which means our range of action is very limited. So you limit your range of action substantially because your mental model and the mental model that gets downloaded into your company from the top down cannot see beyond that, because all we want is to protect, to detect, and respond. And it feels like that's enough. So why would we do anything else? Well, by doing that, you're effectively limiting your range of action in the adversarial engagement space to that little quadrant over there. How can we be more proactive about it? These quadrants provide an antidote to, I realize I don't have the thingy, the wireless thingy. So the different engagement domains of active defense will allow you, or will provide an antidote to your tactical disadvantages as a cyber defender. Environmental volatility, your environment changes too much. You may think you have the correct picture of your environment, but I dare you to really tell me if you really believe you know where traffic is coming in, how it's going out, how many firewalls are in the middle, proxies, exactly what's going on, what security controls are deployed on the endpoint to prevent a particular attack chain. I can name a random attack chain. Would you know that? It's really hard. Your environment changes. The only way you have to combat that is to continuously scout your environment. How do you scout your environment? Deploy for hunting. Start thinking actively. Don't wait for an alert to pop up. Don't wait for a data breach. Don't wait for, just simply start using intelligence to then look inside your environment. There has to be some prioritization process and etc. And then I've been 2 years building the threat hunting capability in the Commonwealth Bank. So there has been many iterations, many challenges, and what I know is that what the industry says threat hunting is, it's not. It's very different, or at least that's my thinking. Your environment changes, but if you increase your OODA cycles of internal discovery and you're actively trying to evaluate your environment at different points of it, you are pen testing your applications, you are running purple teaming or red teaming on your applications, your environment, you will start getting a better picture of your infrastructure. Not what the auditors, or let's say not what the audit picture is, but a more realistic picture. Not because the audit fails, sometimes the audit is cool, but it's a snapshot, it's a point in time. Your operations need to keep up. What is the antidote for signal ambiguity? So the signal to noise ratio, the needle in the haystack. You need to start doing your internal scouting, but you also need to start doing some reconnaissance. Because when you do reconnaissance, when you deploy an intel capability on the outside, you start learning of how things work, how the threat actors move, and that will help you tune the noise out and amplify the signal in your SIEM, in your XDR, MDR, EDR, and all the DRs. Attack vector uncertainty, the best way to achieve or to create an antidote for that is by combining all of these three quadrants that are normally not considered within a static or more reactive cyber defense. Now, I don't like to think in terms of teams. So what does the threat intel team does versus the incident response team? When you start thinking in terms of teams, you're missing a big point here. It's not about teams, it's about functions and what those functions solve. So what problem are those functions solving for your company? I call this the active defense pipeline, and you can see some of that in my newsletter. But if you think in terms of what are the problems my organization have, what sort of functions do I need to address those problems? And then you can create teams, but sometimes teams will be cross-functional. They don't have to be limited to a single thing. But I know people like to put things in boxes, and they like to tuck it away, and they like to call themselves, I'm from this team. Look, it's been 2 years building the threat hunting team in CVA. We have a dedicated team of threat hunters. Don't think there's many places that do that. But what I have to say is that we work a lot with Intel, we work a lot with the SOC analysts, and we also work a lot with IR, because why wouldn't you? I mean, it's part of it. But where does the team start and end is the function that matters. So don't take those words in there with, fully seriously. Just take it with a pinch of salt. These are just some ideas. These are just some pointers into this direction. You can see interception. This is the shadow servers, guys. So when you deploy cyber deception, when you deploy lures, decoys to lure the attackers to fake assets, you're doubling up. You're introducing ambiguity on their side because they don't know what they're targeting. They think they might be targeting the real asset, but perhaps they're not. What if they're targeting some asset under your company's domain? They may think it's a vulnerable instance of some application you're running, but it's not. It's been planted there on purpose by the defenders. That's one way to introduce ambiguity, and on the same time, you learn from them. But why is this disruptive? It is disruptive because you're making them waste time. You are building what I call a control attack path. The goal of deception is to influence attackers' behavior. And if you do deception well, you can build a controlled attack path that you control. You know exactly what's going on there. So you just watch it happen, and you collect information as that unfolds. Lawful takedowns, this is what the shadow servers guys do as well. What you need to start thinking with this model is, how can I implement disruptive external operations with my business? So how can I enroll the help of a third party, or do it myself? My internal team's doing it for me, to perform lawful takedowns, to sinkhole threats that I discover inside my network. Tradecraft burn. This is something that is very contentious. Some people think, yeah, let's do it, and some people think, oh, no. Tradecraft burn is when you get targeted. You may not know whether you are being targeted or not, but let's say some user clicks on a phishing email link, they download some Word document that is weaponized, has a macro, maybe some new vulnerability that nobody knows about, or that should have been patched 2 months ago and wasn't patched. And they execute the second stage, they download the second stage payload, and it might be a reverse shell, it might be ransomware, who knows. So normally here's where the IR teams go, if I upload this piece of malware to Virus Total, then I'm letting all the threat actors know that I know about them. So they know I know, and they know I know, who knows? And then IR teams normally are very conservative and go, no, I'm not going to submit this to Virus Total, because then I will be giving away, I'm going to allow the threat actor to pivot off the environment or pivot technique and do something else. Now guess what? If you do that internally, if you, for example, identify a reverse shell and then you blacklist it internally in your environment, and suddenly the threat actor who is running some C2 server on the other side, those beacons stop beaconing, they will know that you know, because they will know that now you've burned whatever. It might be a technical error, it could have been some other problem, but for the most part, they know that you've taken down a big portion of their beacons. What they would normally do is, whatever beacons are left, they will use them as vectors to redeploy a different type of reverse shell and continue persistence. So you are burning that tradecraft internally. The question is, do you want to burn it externally as well? You can do tradecraft burn externally. I know it's contentious. It's a decision that every IR team needs to do out there. Oof, time. There's another aspect of active defense. What is the absolute goal of active defense? The goal is resiliency. So you want to build resilient systems. We know that if you want to build a resilient system, and by system I mean people, process, and technology, not just the technology, just people, process, and technology in unison as a system, you want that to be the most resilient it can be. Why? Because you cannot avoid damage. You cannot. You won't be able to avoid some sort of damage somehow. The question is, how quickly do you get up? The question is how quickly and how efficiently your assets and your services are back full in production mode and online. That's the question. It is a question about being resilient, guys. And there's some really nice NIST publication whose ID I tried to memorize and I couldn't, but it's called something like Building Resilient Cyber Systems. It's awesome. It's awesome. I read it a lot. So the goal of active defense is to be resilient, but active defense is a spectrum, all right? You cannot be fully active and, oh, I'm doing all the cool stuff, I'm doing all the shadow server stuff, seeing cold laying, and I'm deploying decoys and lures and collecting threat intelligence and etc. Yeah, I mean, that's awesome. That's actually quite fun. But you also have to do all the other stages to get there. You need an IR capability. You have to, because when something goes down, when something happens, you need an emergency response team containing that situation. So the journey goes from being passive to being adaptive. What is adaptive defense? Don't ask me, because I'm still trying to define that. I have a lot of pointers, but what I can say is that there is a leap between being passive and reactive to being active and proactive, and there is another leap to adaptive. What's the difference between being active and proactive, Diego? So are you just stringing some IVE, some words that end in IVE, and then just putting them in? Well, yeah, I kind of did that, actually. But there's also meaning behind this. It's just I developed that. There's a lot of thoughts in my head, and then they go out into the blog. The difference between active and proactive is how you face this, and it's about anticipation. So purely being active, I don't know, let's say it's going to rain, and an active person would go, cool, it's raining, I'm going to quicken my pace and find some shelter. A proactive person would have looked into their app and known that it was going to rain in a few hours, so they would have an umbrella ready. So it's about your intentional ability to anticipate and predict what's going on. I'm going to quickly run through these. These are some of the things I've already spoken about. This is the domain of interception, and our goal, like I said, is to try to interfere with the trajectory of threat actors. Why? Because we all are familiar with the pyramid of pain. So the pyramid of pain very clearly states that it is easy to change an IOC. It's easy to change the hash of a reverse shell or a shellcode piece. It is easy to change the URL for a C2 or a Evil Engines server. Yes, but it's really hard to change your whole infrastructure and your modus operandi. It's really hard to change the mode of operations. Your learned behaviors, guys, because behind all of these, there is people still. There's a huge layer of AI now, but behind the layer of AI, there is people. So the layer of AI has to produce an output that is understandable by human brains. Still. Maybe one day when we have quantum computing and AI and this AGI, I don't know how the future is going to look like. But we want to interfere with that learned behaviors from attackers. That is the point of interception. Reconnaissance is basically intel. So not sitting passively inside your castle thinking that, oh, I built 30 walls between me and the outside world. Surely this is enough. Surely this is enough. But if you're not looking outside and trying to understand how threat actors are behaving, what is their tradecraft, how do they execute their attack chains, what kind of attack graphs they create. You may have built a wall that was not high enough or the wrong material. How do you know that? You may have built 30 walls with moats in the middle that are actually inconsequential to a particular attack chain. Maybe they come flying. And then your walls don't matter anymore. In the realm of scouting, you have hunting, emulation, deception, and tabletop exercises. Just let's recap to say that scouting is all about understanding, probing your internal environment. Your internal environment is just a lake of data changing constantly. You have to intentionally, active defense, intentionally probe it. Threat hunting, guys, is nothing else than probing your data. Adversarial emulation, pen test, red team, purple, is probing your controls and defenses. Adversarial emulation, when you bring in a purple team, or if you have an in-house purple team, or you bring in a red team or a pen test, what they're trying to do is they're trying to show you this is what a needle looks like. This is how I was successful in executing this attack chain and compromising, pawning your DCs for the 10th time. This is how a needle looks like. This is the attack chain. These are the vectors combined. Threat hunting is, oh, thank you, adversarial emulators. I know how a needle looks like in my environment now. I'm going to probe my data to find something that resembles that needle. And I'm running out of time, so I'm just going to quickly skim through this. A few things, resilience, cyber defense. If I want you guys to have some key takeaways, active defense, the purpose is to make your organization a very difficult target, very onerous to attack, to actually significantly reduce the return on investment by the threat actors on their operations. You cannot avoid engaging cyber attackers, guys. If there's something I want you to walk away with today, is you cannot avoid that. So start thinking, how am I going to approach this adversarial engagement space from now on? And it is a spectrum. So that's it for today. Thank you very much. I hope it was entertaining, and I appreciate your presence today. Thank you. Thanks, mate.
We're a little bit short on time, but you have a lot of really good questions here, so you're going to be very popular at lunch. I'm just going to merge two of them in, which I think will be the most valuable. How do we measure and justify these kinds of activities, and where do we start?
Where do we start? So how do you measure and justify? You have to build a business case to convince the top guys, that's for sure. The way that you justify this is to start measuring the cost of not doing it. So how many attacks you may not be protecting against, how many controls you don't fully understand. So bringing in a pen test, bringing in a red team, bringing in some purple teaming into your organization is a good start, because it will start highlighting those gaps. You can use that then to measure control efficacy and gaps, and then use that to start building a business case for a more proactive space. And the way you start is that you don't just start with a clean and clear, let's say, fully staffed threat hunt team. You start grabbing your IR guys, your SOC analysts, and moving them into more proactive activities. If that pays off, because you have to measure that output, if that pays off, you have another way to justify investment in something like this.
Awesome. Thank you so much. Okay, please get another round of applause. Thank you.
Thank you.
That was awesome.